5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Inflatable space modules is what we are talking about in this episode. And that is what Max Space's product is. And they are coming out publicly today at Space Symposium. My guest for the episode is CEO and co-founder Aaron Kammer, who some of you may remember from his previous role as a co-founder of the in-space manufacturing company Made in Space. Aaron and I talk about his motivation to set up Max Space and how their inflatables can be used, for example, as habitats, research labs, manufacturing sites, and even as sports and entertainment venues in space. Enjoy.
My name is Raphael Röttgen, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nano Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with their CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu.
And just some final things before we start the episode about ourselves. If you enjoy the podcast, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. If you want us help expand our work, you can do so and support us at www.patreon.com/Space Business Podcast. And we'll also put that link in the episode notes. And lastly, you can follow us on Twitter at podcast_space.
Hey, space enthusiasts. Welcome back to another episode of the Space Business Podcast. I'm very excited. We have a serial space entrepreneur as our guest today. It's Aaron Kammer, formerly co-founder of Made in Space, and now here in his new role as a co-founder and CEO of Max Space. Welcome, Aaron.
Hey, Raphael. How are you doing today? Thanks for having me.
Yeah, it's a pleasure. So, Max Space, tell us all about the new gig, please.
Yes. I like naming things what they do. You know, my prior company, Made in Space, I named it because we made things in space. We did the first in-space manufacturing. And Max Space, we also do what the name is. We get you the maximum amount of space in space. And so we are basically building inflatable or expandable habitats to get orders of magnitude over 100-fold in terms of improvement of cost per cubic meter in space. And so we look at it as a kind of building the real estate infrastructure for the future of humanity in space. And if you think about all the stuff that we do down here on Earth, working and living and playing, and it all involves being in somewhere. And the somewhere in space is actually very limited. I like to say space is space limited currently right now. And so Max Space is built to really solve that problem.
Well, space limited in terms of space that can house humans.
Exactly.
Humans so they survive, or machinery so it can be productive and things like that.
That's right.
What is sort of you obviously were very successful previously with Made in Space, right? And I assume there was a time when you guys exited, you got acquired by Made in Space, got acquired by Redwire, now publicly listed company. Yeah. You probably could have done many things. I mean, you obviously you're very knowledgeable on space. You have probably an extremely good network, so you could have looked at many different options. What was the thought process? Maybe like also the vision that led you to decide on doing Max Space.
Yeah. I think we at Made in Space, we did a lot of work on the space station. I think we were told many times we were at least in the top 2 or 3 companies that were actually performing consistent payloads. We had our own ground station where we daily were working on the ISS, and we were up there with companies like NanoRack who also are working daily on the ISS. And the thing that I learned is any type of, let's say, non-constellation satellite work, any non-satellite work, really, like any type of in-space manufacturing, biopharmaceuticals, space research, and more was just really limited by 2 things. Number 1 was crew time, and then number 2 was volume, or actually a place to work. So as an example, we made the first ZBLAN which is an optical fiber with the most optimized attenuation. It could be used for things like transatlantic cables without repeaters. It could be like a game changing technology that could change how we do communications down here on Earth. And we made that fiber in space, but all of the work, it was a multi-year program. All of the work was really designed around fitting the fiber manufacturing into a locker-sized payload. And so we were very, very limited in terms of volume. Because Z-band today on the ground is made in like a 3-story kind of system, very large system. And so it's all about reducing the volume. And that's really where a lot of the engineering kind of came into. And so I use this as an example. There's many other examples just working on the space station, where there wasn't a lot of real estate or volume to kind of do things up there. And so the ISS, it cost $100 billion and 60 launches to essentially, make. It took several decades, and that's for 1,000 cubic meters. 1,000 cubic meters is really not a lot of volume. And so I really thought about, okay, how can we, reinvent this problem? How can we fix it? And I knew about prior companies working on space inflatables. A company called Bigelow Aerospace had done it early on in the 2000s. NASA was doing it with something called Transhab. And so there was a legacy of inflatables. And the more I looked, the more I realized inflatables or expandables is the future. It's the way that you can get a lot more volume for kind of cheaper. And that's when I met my co-founder, a guy named Maxim de Jong, and he is what I like to say is like the godfather of space inflatable habitats. He's been building essentially inflatables for over 2 decades now. He's built over 40 pressure shells. There's been three inflatable habitats actually to go to space. He designed all 3 of them, and he built 2 of them, the pressure shells for those. And so we teamed up, basically taking my space station operational experience and his inflatable habitat experience to create Max Space to really innovate and on how you get this more volume in space. Yeah.
So it's interesting. You mentioned this history there, and thanks for mentioning that we have 3 modules. I think all three still in space, right? And one at the beam, I think, is attached still to the ISS. Like, why do you think inflatables? Because they seem to have so many advantages, which we'll talk about in more detail. Why do you think it hasn't happened more in the past? Were there like any sort of, constraints on material science, or was it just like decision making that things just went down another way with aluminum structures on the ISS, or was there any other reason in your view?
Yeah. I mean, I think in the early days of the station, it was let's build a pressure vessel that and get it up there. And the most straightforward way to do that was just take aluminum and titanium structures. It wasn't designed, I think, from like a commercial standpoint, which is, how can we build this in the most cost-effective way? And so I think, obviously, like with companies like SpaceX and the new space industry, commercially driven is kind of the future of new space. And so you have to kind of think, all right, how do I get, we obviously can't spend $100 billion on the next station. And then, you'd have to get over $100 billion of kind of gross profit value out of it to kind of justify it. So I think a big part of it's just economically there wasn't that driving factor that there is now. And then now also the timing's really, really great, I think, for true business in space. Like unlike any other time in history, we now have like much more affordable, reliable launch to space, right? Like multiple times this year, SpaceX has flown at least 3 times in one day. And that's kind of crazy to think about. Like when I first created Main Space in 2010, me and my co-founders, like launch was very rare, right? It was often like once a month. And to think like 3 times a day, it's the cost is getting cheaper and the frequency is getting more. And so now we kind of need a place to go. And so that's where it's like, okay, now how do we get some affordable real estate space? I think that's the next bottleneck to kind of solve for space. Yeah.
Yeah, and then it's interesting. Of course, rightfully, you mentioned the real estate we have right now is very limited. I mean, as you know, I'm also involved in some in-space manufacturing, not Z-Plan, but more life sciences use cases. And as are some other companies, right? And everybody at the moment is using the ISS, and it is really quite limited space, as you point out. And then the only alternatives we currently have to that is like the Chinese space station, which for most of us is geopolitically not really feasible to use. Or we could go to SpaceX and get an entire Dragon capsule, which is economically not, realistic to do that. And then I guess that's why also you have people like VADA doing their own capsule for in-space manufacturing, because they just want to control their own space. And it's actually also interesting because if you talk a little bit about use cases for a few minutes, okay, is that in-space manufacturing? I totally aligned with you there. I guess the other thing where you feel how cramped the ISS is just for the crew, right? And including the occasional space tourists who visit. I mean, those poor guys, they pay like, I think, right now the price is $65 million, and
Keeps
you're like
going
in
up.
a really cramped environment with like, like some sort of stand up, well, it doesn't matter, but like really tight sleeping, basically almost like a big sleeping bag. There's no shower. There's like really nothing. That's another use case, right? Like the space tourism, I assume.
Yeah. That's great to bring that up. Like Inspiration 4, that was an amazing and inspirational mission. I loved it. But when you think about it, it flew 4 people on a Dragon capsule for 3 days, and they were in basically 9.7 cubic meters. It's like roughly the size of like a little bit bigger than a bathroom, and for 4 people. And for, like you said, $65 million. The price keeps going up, by the way. People keep asking me, when's it going to get cheaper? The tourist price is going up. It was $25 million, a couple decades ago. Wish I would have been able to fly when it was on the cheaper price. But yeah, so if you fly, 4 people in roughly, let's say a large bathroom, man, that's not really fun. Right. And so what we're going to do is, for just a fraction addition to the cost of Dragon mission, you can get 10 times the volume, immediately for like a pop-up module, you'd say. And so you could start doing a lot of interesting things there. You could have tourists in bedrooms and not just have a sleeping bag, but have your own room. You could have a big, large play area like they did on Skylab. If you want to see some cool videos of of fun and exciting things that tourists might be able to do, check out the Skylab video. But we also do like entertainment in space, movie production will actually become actually possible. Sports in space. That's I've done 400 parabolas myself on the zero gravity aircraft, and ever since then, always have been like, sports is going to be amazing in space once that happens, and so we have designs for really large scale, kind of sporting stuff you could do in space. But yeah, all of these things, I think you highlight, not just the industry, the working side, like in space production, but also the living side, humans and people, and having a place where they can, humans like to kind of spread out, right? And it's kind of, you see that on Earth, people, buy bigger and bigger homes, try to get bigger and bigger hotel rooms. And I think that is also going to be the case when we go to space. And so I think it's a serious need.
But there's various use cases we mentioned. So some quote unquote established, right? Like, in space experiments, and then manufacturing, I guess, and tourism are more established. And then you mentioned some emerging ones, like, which we haven't really seen that much in space, if at all yet, like entertainment and sports. Are there any others? Are there some that you are particularly excited about? And also, if you had to take a guess, how do you see the sequencing going as you introduce your product to the market?
Yeah, it's a great question. I definitely think what we'll push for is I say unfortunately, but it is fortunate. Unfortunately, the non-human stuff first. I say unfortunately because it's a big reason I'm even doing this company is is more room for more humans to go to space. And but I think anything that involves humans, you need to be a little bit extra careful. And so I do think the areas that we're looking at first is like the non-human robotic powered stuff, so more like robotic modules, and that could involve things like we've been talking about industry wise and production wise, but it can also involve things that are much more basic, like storage. This is, where we started getting contracts for already is using our modules to store goods and things that you would want both in space or want to deliver back to Earth really, really fast. And kind of having a warehouse in space is really useful. And when you have a place you can store things, you could store, let's say you do some on-space production, store it, bring it back, but also you could store things like fuel, right? Or, propeller depots and things like that. And so, again, that might not seem like an obvious like real estate use case, but no, it is. Like you need a place to kind of put fuel if you're going to store fuel, as an example.
I mean, I must say, without going into too much detail on the storage, but I find that fascinating, right? Because you think about it in theory, it's like the ultimate like warehouse in that it's always local to or because if it's in low Earth orbit, right, then every 90 minutes on average, like let's say it was equatorial, like it's going to be close to some points on Earth, right? And basically within a few minutes of delivering stuff back. I'm like trivializing obviously the re-entry and everything else, but it's a very interesting concept. The storage. And so how are you gonna, business model wise, how is this gonna work? Are you gonna sell the modules to people, or are you gonna rent them, or have you guys decided? Do you do both, or?
It's definitely a kind of a both category. So there's a lot of companies building stations right now, and we're working with a lot of them, and I honestly want to work with all of them. I look at a lot of these, a lot of movement in the space station realm is centered around the commercial LEO destination initiatives that NASA has put together. And we've designed our system to really work with all CLD providers. We almost look at, a lot of one of them kind of mentioned that they look at their space station almost like a space station satellite bus, where they provide power, docking ports, peakless life support. And I think that works perfectly for us. And then, we kind of provide the large, real estate kind of for them, having the usable, kind of space. If the ISS, as an example, was going to continue, we would be adding a module to them and really, trying to 2x their volume right away. And so I think it'll be both. They'll depending, there's different for each applications. Selling modules for sure, renting modules. Definitely doing in some cases with certain customers right now, what we're working on is like basically case by case custom missions and more custom modules depending on what kind of the customer needs and wants. And so there's a little bit of mission development in there as well. And so I think it's both the selling, renting, but also mission development, whereas a lot of the business kind of aspects is coming from. And then of course operating the modules and helping maintain and make sure they're structurally sound on orbit and et cetera is another kind of business avenue. And so that's currently how things are going, Raphael.
Okay. And so this is an interesting point you bring up. So like in terms of customization, right? Because at the end of the day, your product, what makes it really interesting, I look at it, this thing is basically like a platform, right? And you can do like many different things on that platform, right? And then depending what you do, let's say you do do something like a high-end tourist destination, like a hotel or something, right? Then you would need some sort of certain fit out for that, which is going to be completely different from a fit out for, I don't know, a certain industrial in-space manufacturing use case. And will that be you guys who do this customization, or do you imagine like partnering up to kind of like almost opening up the platform for like an app ecosystem, for the lack of a better word, where other people can come up with customization ideas and market them?
Yeah. Well, right now, most of it is us doing like the spearheading of the customization with different customers that are tackling the different areas we talked about, like in space manufacturing, in space production, tourism, entertainment, storage, etc. So most of it's like coming from us and us driving, working with customers on the mission development now. I think as the platform kind of gets more mature, it'll be, we'll have, platform requirements that people can easily customize their own missions. Similar to how like the iPhone was, the first apps,
Exactly.
they worked with Google for the first Google Map app as an example. And so I think in the beginning, especially like this, I would say what the space station market for the next at least 5 years is still early, and probably really for the next, if I'm being fully honest, the next decade. It's still on that early adopter stage of the market. And I think that as the market kind of matures, that's what it'll be more, a more hands-on customization approach will be needed. Of course, like our goal and dream is to essentially work with all the interesting space companies that need a place to go, and really to provide the most real estate in space. And we look at how many cubic meters. If I think our measurement is what we look at is in a decade. Do we have the most real estate provided in space a decade from now? And if so, then I think we've done a successful kind of job. If we're not just having, again, the ISS is 1,000 cubic meters, but can we have tens of thousands of cubic meters in orbit, in cislunar orbit, on the moon, et cetera?
I think that, the real estate comparison is a good one, right? But then that's, again, the way it usually works on Earth. You're somebody providing the actual physical real estate, right? And then you have different people, like anchor tenants, operating whatever it is, like an office complex or a warehouse complex or a hotel or something like that. And I guess that's what will evolve over time. If people want to sort of get creative, for use cases for your platform, is there going to be some sort of user guide with specs being released that people can look up?
Yeah, for sure, absolutely. And I think that like that example you just laid is great. Like if you've set up like a workshop in an industrial park or anything like that, you know that like the landlord will often work with you to kind of customize the building to your needs. Right. That's kind of similar to what we're, doing here, right? With you take our module and then we'll integrate it with robotics, but maybe you need, the people using robotics for an in-space production of pharmaceuticals would be different than somebody using robotics for some type of entertainment VR play, for instance. And so I think that there's like a lot. I think that's how it'll play out over the next 5 years. A lot of customization kind of happening to really leverage the space properly.
Let's talk a little bit. You mentioned how also you personally are excited about sort of the human, the crude use case, like humans using this. Mm-hmm. So just to delve a little bit further into this. So then of course you fly humans, you need like a life support system, but I assume obviously you guys have looked at it's feasible to fit a life support system within a inflatable environment as well.
Yeah. So we're currently not developing life support systems today. There's a lot of companies like Paragon and others that have been developing those for years, and a lot of companies kind of working on that, and that I think can hopefully solve this problem. If it's not, then we would have to by in the next few years, if it's not solved more and more, and making it easier and cheaper to get proper life support, then I think it's something we look at. But I look at the market, I look at companies. I'm confident that this won't be like a bottleneck as much as let's say like real estate is. And it was something we looked at early on. It was like, okay, what is more of a bottleneck to more humans in space over the next 5 or 10 years? So we were very forward thinking and thinking, okay, Starship's going to come online, New Glenn's going to come online. Okay, then let's say you want to have large space hotels in space. What's going to be the biggest roadblock? And we really honed in on this real estate problem. Yeah.
Gotcha. And then sort of I guess related to life support, things like other threats in space, like micrometeorites, space debris, radiation. I don't know, you guys looked at any of this, how that compares like the inflatable environment to like the aluminum type environment of a space station.
I'm glad you brought this up because it's maybe we should have discussed it sooner because it's one of the first things that a lot of people think about. It's like, oh no, an inflatable habitat is this like, my inflatable mattress, is it going to pop? And
It's like a kid's balloon. It's gonna pop.
yeah, exactly. And so in short, inflatables themselves, and especially ours systems, are stronger and more reliable than like a hard goods system. It's multiple layers. Right? We have at least a half a dozen different layers of really strong material like Kevlar, like bulletproof Kevlar. Other materials like Vectran, which is a Kevlar-like flexible material. These are all designed. We have a micrometeorite impact shielding, orbital debris shielding, or MMOD shielding, and this is designed, in the instance that it does get hit with orbital debris, with the Kessler effect. This is a big worry, especially as more and more constellation satellites are going up, and presumably there'll be more and more orbital debris. So all space stations today have to be designed with thinking about orbital debris, and so we have really robust shielding that goes on the habitats, and in fact the shielding is robust enough that we've one application that that has been looked at and kind of requested is, can we use that shielding to shield satellites, as an example. If probably with Starlink it's not as big of a deal if like 10 of their satellites get hit with orbital debris, but you can imagine next generation James Webb telescopes that cost billions of dollars to put up there, and it gets hit with orbital debris. That would be very, very bad. And so it's definitely a focus of the company. Definitely something our technology is adaptable for. Yeah.
Very interesting. By the way, speaking of other space stations, including the ISS, so slightly different question. I mean, the ISS now, I guess 2030 is really seen as sort of the end of the ISS, and now there's these plans are being started being drafted, like basically how to deorbit the entire ISS, right? Is there any sort of like end of life planning you guys are already thinking about for the inflatables? Like, would you expect that people bring them back to the atmosphere to burn up, or could you even sort of like pack them together again and sort of like reuse them, or have you guys thought about this?
I mean, deflate and bring them home would be interesting. A company that I actually invested in was one of my co-founders of Maiden Space, Jason Dunn. He started a company called Outpost, and which I helped him get going as their first investor, and the company is got a really, really unique way to do high precision landing on Earth from space very, very cheaply, which is important. You need not just high precision, but you need to do it cost effectively. There's also companies like Varda as well. And so, I think that that'll become more and more feasible as there's more down mass happening, where you don't need to just do what we're doing with the ISS, which is burn it up in the atmosphere. And especially since the system, is built to be packed tightly. I don't think our first ones are going to be this by any means, but like when you think like long term, yeah. I also, I also think it takes so much money to get the real estate up there. I think trying to optimize as much of it for as much time as possible as you possibly can, is a good idea.
I mean, have you guys thought about sort of what the lifetime would be of one of these modules, and what's governing that? Like, what are sort of the restraining factors of a lifetime of an inflatable module?
Yeah. No, I mean, a lot of it is, essentially building in structural reliability that can last a decade, and so and then testing it, for longer periods of time. And so our first modules aren't going to be designed to guarantee a decade. We're like startup philosophy, move fast, and get some modules in space that can be useful right now, cost effectively. But the but essentially, the architecture is designed to last decades, right? And so, Maxim, my co-founder, built the pressure hulls for Genesis 1 and 2, and those are actually still in space today, and it's been almost 2 decades. And so, Beam is almost, it's crazy to think it's almost a decade old. Beam being the inflatable that's on the space station now.
Mm-hmm.
And so, the architecture is definitely designed, or coming from the form factor of, hey, let's have something that can last for decades. Yeah.
And so we're actually, I realize we're speaking now a lot about space stations, and hence by definition at the moment lower of orbit, because that's currently where our space stations are. But
Yeah.
It's an audio podcast and our listeners can't see, but your background right now is like the lunar surface. I mean, do you envision also the use of inflatables in other destinations like the moon or even Mars, or somewhere else in space?
Yeah. We haven't talked about the moon because orbit is just, closer, both in terms of proximity and in time. But my friends, they actually call me Mr. Moon, because I tell everybody, hey, my dream is to, help build a city on the moon before I die. I say help because it's going to be, companies like Prometheus, MaxSpace, Outpost, and hundreds of others, kind of coming together to make this happen. And really, I mean, that's, I'm fortunate enough to get to spend my time on things that I want to be spending my time on. And so every day I ask myself, hey, is this helping more toward that vision? And MaxSpace definitely is. I mean, the only alternative, I think, to having large scale inflatable structures on the moon would be making, producing structures in situ. And at my last company, MainSpace, we looked at this a lot, right? We did centering of lunar regolith, taking moon dirt and making bricks and buildings, and Redwire is doing a great job carrying on that, that vision now. And they're working closely with NASA to build some exciting stuff like landing pads and roads and more. But if I think about pressurized volume for humans on the moon, I still think that's still a couple decades away. And meanwhile, you can take an inflatable MaxSpace module, put it inside a Starship or New Glenn, and get a lot of volume, to thousands of cubic meters, and you can house a lot of people. And just kind of as a reference point, like one of our midterm missions, we're going to launch 1,000 cubic meter inside a Falcon sized vehicle. And so that's basically one international space station in one launch, right? And that's again, very disruptive because it took them 60 launches to build the ISS today. And so, taking that and putting many of those on the moon, I think is the, long-term goal and dream here. Yeah.
So I don't remember the sort of the payload volume of the Falcon 9 we're talking about here, right? So what's the expansion ratio here from?
That one's like a 20x. You can get like over 20x Falcon 9. For our bigger systems, like in Starship, you should be able to get up to a 50x. And so that's really big. Yeah.
So okay, and let's say we're like in, I think we're both probably very much SpaceX fans. I certainly am, and I can't wait for like Starship World. And let's say we have a regular flying Starship at, really very cheap prices. Elon sometimes talking sort of basically like $10 million a launch or so, right?
Oh, that'd be great.
If you were to,
me and you are going together on a flight.
Yeah, totally. You mean like an inflatable.
So let's say you pack. Yeah, so you pack.
Yeah.
I think where you're going is you pack like a Starship filled with 100 people, because that's really some of the numbers that I've said, and said, hey, can we get 100 people for, $100,000, $200,000 per person? Well, 100 people, they're going to still be into that problem that, we would run into with the current Dragon, where it's 100 people in there is not a lot of room. So now we need a place to go. And so, yeah, you would cheaply build a, like you take that and you 50x the volume, and everybody gets their own large room, and you could get, essentially a hotel, for those 100 people as a place to kind of go. And so that's exactly it. That's the
I
dream.
mean, this start really seem like really big, like you said, like a lot of space, I guess, hence really a very appropriate name, max space. So, I mean, let's say if you didn't actually have, I think you guys ran these simulations, right? If you didn't have any people, if you just packed the Starship with an inflatable, I mean, how much volume are we talking about here? It just seems like it would be ludicrously big.
Yeah. Over 50,000 cubic meters. Imagine a stadium in space is where we want to get to. And
like a football stadium?
Yeah, football stadium, like a World Cup, or Space Cup, we'll call it.
Okay.
And so you fly, I don't know, 10 starships filled with, 1,000 people to go watch, the first Space Cup in space, and that's the dream. That's really where I want to get to is Space Cup, in orbit, and then Space Cup on the moon, or Moon Cup. And so, yeah, you imagine, you can see the moon background behind me. Imagine a large stadium right there. And and I think this is that technology that you would do it with. I think it's also very adaptable, where a lot of or nearly every other station architecture is not. And what I mean by that is, inside a lava tube, kind of on the moon, you could inflate, and it could conform to the area around it. And you can't really take like an aluminum module, for instance, and just shove it in a lot. I mean, you could, but you have to be very careful. Kind of with, it's not going to conform to the shape around it.
But we're talking about conforming, like adapting to shapes. Stupid question, but I haven't answered yet. So the pictures of inflatables I've seen, that they literally look like inflatables, like something you blew up, and it's something that's inflated, and it's like, for example, there's no windows. Is it like easy to actually do things like that, fit windows in there, or other structures you want to fit in there?
Yeah, I mean, I think the architecture itself is built to integrate with other hard goods systems. And so as an example, things that you probably aren't going to inflate anytime soon, like windows. And you ask crew, you ask astronauts, like what's the things that they want more? They always want more space and more windows. Those are like the big two asks if for people space. And so we integrate really well with windows. You're also not going to inflate electronics. And so we're designed to integrate well with windows, electronics, robotics. I think the earlier versions are going to have a decent amount of hard goods, like conforming to the space station standards of the lockers and racks, that most station payloads are designed for. I'm guessing that Prometheus is designing, to go in a locker or multiple lockers as an example. And so you can integrate really well there and still get like a 10x, even, I think that a lot of our earlier designs has like a 10x volume increase while integrating with hard goods. But I think where it gets is you can inflate a lot more than you realize. So like, let's say like a crew or a hotel, you can inflate beds, walls, furniture, storage. If you look at the ISS today, most of the volume is actually just open volume. If you can just do like the virtual tour, or if you get the chance, I highly recommend going on a Felix and Paul VR studio tour of the ISS. It's a VR production studio that spent 3 years capturing the International Space Station, and they built almost an hour-long virtual reality experience where you can actually go through the ISS. highly recommend it. They're touring the US and North America currently. But if you do that, or if you just go online and watch the videos, you'll notice that the large majority of the space is actually just open space. And that's, and you kind of really get, it's like, oh, okay, I can see, here's how we're using space today. We're going to continue to use space as an open space. If you look around you, you realize even down on Earth, most of the space is open space. If if you're looking in your hotel room, since Raphael, you travel more than anybody in the world, the there your bed, the couch, the chair, the dresser, all this stuff can actually be inflated with like strong material. Yeah.
Stupid question. How does the inflation actually work? So like you get up to, you're going to Falcon 9, it's packed up, you get to like your target location. How does it get inflated?
Yeah, like compressed air. Very simple mechanism. You would use the same atmosphere that you need, for to live and breathe, essentially. And
then from compressed air, I must admit, I don't know, but I mean, the word describes it, right? That also has a probably very stupidly high expansion factor. And so
exactly.
I guess
very, very high, even higher than our inflatables. Yeah, very, very high. So use that to inflate, and then it's maintained fairly easily. Kind of due to already the differential in pressure. Yeah.
So when are we going to see the first module in space?
Great question. We really believe in flying fast and iterating, and so we're targeting our first mission in roughly 2 years from now. I'd love to actually go quicker, but we want to do it right. And so trying to go quickly and then really fly regularly after that. First 1 and 2, the next one within a year after that, and really just basically start calculating like our KPI in the company is how many cubic meters do we have in space. And right now it's 0. In 2 years, it's going to be, we're gonna have some, and then hopefully in 5 years, we've more than the ISS, and then hopefully in 10 years it's tens of ISSs, kind of, and maybe even Space Cup kind of happening. Yeah.
The stadium, or
the stadium.
Also like the idea of like you're like the concert hall, right? Like I imagine like you have like U2 floating in the middle, and then like tons of spectators floating 3-dimensionally around. It'd be like cooler than the Sphere in Las Vegas or something. Again, it's like unlimited imagination for use cases for this as a platform. And the first one you're going to fly, how large is that going to be?
That one's going to be sub 100 cubic meters, and at least 20 cubic meters. It's in that range. And it'll be the largest space inflatable to fly to space. It'll be bigger than Beam and Genesis 1 and 2. And it'll be like a 10x. Really what we're demonstrating here is like the getting space heritage on the architecture, and at least a 10x expansion improvement. Yeah.
And what are sort of the major to-dos in the company to get there? For example, do you guys still have to like run certain tests on the ground? I think with things like that, there's like burst tests and these types of things.
Yeah. No, great question. So we've already done burst testing, vacuum testing, vibe testing. It's on the architecture. And it's actually been in development by Max, my co-founder, for several years. And we already have a full fidelity ground unit of the system. And now it's basically integrating it into a spacecraft and getting the MMOD shielding. Kind of the final 2 components. And so really just following, going down that kind of checklist. We're manifested on SpaceX to fly, like I was saying, within 2 years. And yeah. And so really kind of confident in the architecture itself, and just kind of integrating it into a system, integrating it into launch, into the vehicle, and integrating it with a spacecraft. Yeah.
How do you see like the major milestones after that first in space demonstration? Like, what are the next few milestones after that over, pick the right time frame, 5 to 10 years, that you think are significant?
So within 5 years, what I'd love is two big milestones I think are important for me. One is an entire space station in one launch. That I think is meaningful and something that we can actually really accomplish. And then two is humans using this our architecture regularly, and getting it good enough where people can use it and fly and do fun things, do work, do research, kind of. When I see people fly into space on a Dragon capsule, I'm like, man, it would be really great if they had a place to go that they could, really, really kind of have multiples on their output and their productivity, both from a fun standpoint, like having more room to like move around and jump around. And as somebody who has been in zero gravity, I know the more you have to jump around or bounce around and off the wall, so to speak, would be great. Or run around if you do the Skylab, mechanism. But and then also just more room to kind of do more science and research and stuff. So I think that would really be the two big milestones for me. We're like, okay, we'd have a successful 2020s if before this decade is ending by 2029. We've done both of those things. Yeah.
I forgot to ask for the crewed use for putting humans on there. I assume that there's probably some sort of regulatory process, qualification process before humans are allowed to go inside the station, or how does that all work?
Yeah, and so basically following kind of the standard, process for docking, and I think this would be figured out even before you put humans in. Getting goods, out of like storage. There's a lot of like international kind of standards right now for both, kind of docking modules that we had to figure out to make the International Space Station. So just, kind of adapting that, on our, for our inflatables is kind of what we've basically been doing. Yeah, like we're basically designing it to set up so it can coordinate with companies like Outpost and Varda, and for both docking and kind of transport. Taking goods from the module, putting it in a vehicle like Outpost, and then delivering it back home. Yeah.
And so I think we already talked about this, but sort of summarize, like, what is your sort of like grand long-term vision for the company? Is it just like, as you said, the key metric here is, I guess, cubic volume you have in space. I think you said you want to, see those on the moon as well, or like where do you want all of this to be in, like, I don't know, 20 years time or so?
20 years time. Okay, so I like to, like I was saying earlier, I like to tell people my dream is a city on the moon before I die. So the largest variable in there, I think, is not dying. When I first joined the space industry, it's been over 15 years now. I've been like really heavily into space entrepreneurship. And when Made in Space started, we were like cohort one, I would say, along with like companies like Planet Labs, and Satellogic and several others. Cohort 0 is probably like your SpaceX, Blue Origin, Virgin Galactic, like the real, early ones. And so when I first started Main Space, I was like, oh man, I guess we'll be to the moon within a decade, of course. And the naiveness, got to me. So after a decade, I was like, oh man, it's going so slow. Why is this not happening faster? And so essentially what ended up, kind of happening, I really kind of like realized, hey, this might take several decades. And so I think an exciting goal would be uh, continuous 10,000 plus people, with thousands of those people actually living there permanently on the moon. I don't think that's doable in the next 20 years, but I do think it's doable, in the next, my lifetime, the next 30 or 40 years. Probably in the next 20 years, it'd be great to have, several of our Starship class, inflatable systems on the moon, and getting you, hundreds of people, having a place to like work and live. If I'm being realistic, if I'm being optimistic, I'd say no, you can do the thousands of people in the next 20 years. Maybe I'm getting a little too colored by just the space is moving fast now, which is cool. It's super exciting. It's moving way faster than it was 10 years ago, but it's still, every year I'm reminded how much of a ways we have to go. So hundreds of people, tens of these, huge buildings filled with, things like, farms, ISRU facilities, large housing, so people aren't like crammed, government research stations, all this kind of stuff on the moon, which you can have like a serious presence, whether it's on Shackleton Crater or inside, a lava tube. That would be, I would say, job well done. We've accomplished it if that's where we end up in the next 20 years. Yeah.
Well, that's a perfect segue to our traditional two closing questions, because like you said, you've been in the space sector for 15 years now in various roles, and I think you're one of the people that really has a good overview and vision of what's going on. Besides Max Space, what are some of the other things that are happening in the space sector which you find exciting?
Yeah, so I get asked this question quite a bit. Since I've been in the industry for a while. I think for me, the thing I think it's really exciting to be building the next generation infrastructure. If I look at a lot of my like actual ex Maiden Space co-founders that I've, now invested in, there's, one group that Outpost is doing Earth return. The infrastructure of down mass, is a big actual challenge and high precision down mass. Max Space is about building the infrastructure of real estate. I see other groups that I'm excited about investing in. That's, infrastructure for getting more power in space, or infrastructure for, doing a lot more on edge computing in space, and because right now that, the whole system for, getting rad hardening electronics up there that work consistently really slows down. Like, space always lags Earth in terms of computing. And of course, computing right now is, super, super hot and driving a lot of the AI advancements. And I think that'll continue in space. So these are, I feel like at least my shape of space. And I know it's not super sexy to think of infrastructure. I never thought of infrastructure as sexy, but like, I think this decade is about infrastructure. And then the next decade is about killer applications to use that infrastructure.
Infrastructure. Yeah.
If I was going to start a space company, I would either like, all right, I'd try to see if there's a way to build out infrastructure, or be very patient and be prepared to start building out, so I can intercept the infrastructure, that's going to be built in the next, and leverage that infrastructure for good applications. I think a great example of this was SpaceX. It took them a decade to build the infrastructure that gave them Starlink. I would look at launch, as infrastructure in this analogy, or this way I'm thinking about it. But once they had that, now they have like a corner on the internet satellite market, which for decades people have been wanting to do, right? And like decades, and many businesses tried and failed it there, where SpaceX succeeded. So shout out to them. So I think there's so many other exciting applications as well that's going to happen once we get that next generation infrastructure in place. And then once we do that, then I think we can start doing a lot of like fun stuff, space hotels, moon bases, going to Mars, all the stuff we see in For All Mankind. And then eventually, probably not going to happen in my lifetime, but maybe my kids or my grandkids, they'll get to see the Expanse, version of humans,
Real
that
life.
TV show. Yeah, where humans are all over the solar system. Like that's going to happen, at least in the next, I would say 200 years, if I had to guess, definitely within the next 500. But if we keep up our pace within the next 200, if we speed up our pace, maybe even the next 100, that's gonna be really cool.
That's kind of the time frame where relevant sci-fi like Expanse and Star Trek is sort of a few hundred years ahead, which is another perfect segue to our traditionally last question, which is about favorite science fiction and what some of your favorite science fiction is. It could be books, TV series, movies.
Yeah, I mean, Expanse is. I had a chance. I was at Jeff Bezos throws a Mars conference every year with people that are helping out with machine learning, AI, robotics, and space. And so much of what I do actually applies in a lot of those categories. And I got to show Jeff actually the module, that we're going to be flying up before we even kind of went public with it. It was just super cool. But I got to meet the co-creators of the Expanse and had dinner with them. And the Expanse is just so like, if I could like sum up with what excites me on something that's like a practical near-term goal, it's the Expanse. And I say near-term on like the history of humanity, and like the Expanse again is, at least the first arc of the series is about humans being humans, but throughout the solar system. And that's just that's super exciting. And then of course the long term, and actually the Expanse starts going here later in this series, is humans throughout the galaxy and then the universe. And that's a little bit I get excited about that. I get excited a lot about unlocking the secrets to the universe and understanding more about the universe that we live in. But practically I can see a real future in the relative near term, like the next few generations of humans permanently living throughout the solar system. And that's that gets me excited. Yeah. So I'd say Expanse. Expanse is great. I saw 3 Body Problem recently. I read the books, but they're different. The books are different from the show, but both are really good. Recommend both of those. For All Mankind, I think that's another. If you want to get like really, really near term, that's an exciting show to kind of talks about alternate history as if we already went to the moon and Mars. And so a lot of great sci-fi shows out there. Yeah.
Any of those sci-fi works where you like the the way they thought about real estate in space? Well, there's obviously like a few shows. There's like a few famous space stations, right? You have like Star Trek, DS9, you have like Babylon 5, you had in the Expanse, you had Tycho Station, things like that.
Well, I like the Expanse on how they how they were leveraging asteroids, and I do think, if you could just like go to cryosleep for like 5,000 years with like a money manager or something, I would probably say, hey, like, all right, your one instruction is to like, buy as much of this like prime asteroid and a celestial body real estate, in the solar system, because immediately it'll be like, oh, we have so much, there's so many places where we can go, we have unlimited state, but like snap your finger 10,000 years in the future, and if humans keep expanding, you can easily see where the prime real estate spots are. Shout out to the Expanse. Watch that.
I totally endorse it. Everybody who hasn't watched it yet, watch the Expanse. Aaron, it's been an absolute pleasure. Good luck with everything at Max Space. Can't wait to see the first one in orbit, and then I really can't wait to see the arena, the space sports the sports arena.
That one will be fun. All right. Well, thank you, Raphael. Thanks for having me.
Thank you.
Thanks everybody for listening.
It's a pleasure. Thank you.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/spacebusinesspodcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.